Okay, everybody. This is December 14th. This is asynchronous. It's an answer key to your practice final. For the first free response, researchers are trying to estimate a population parameter. They have developed 4 different statistics to be estimators of a population parameter. The researchers decided to test out the behavior of these estimators by selecting 500 random samples from a known population, and each statistic is calculated for each sample. True value of the population parameter is 75. And the graphs below show the distribution of values for each statistic. So kind of our definition for we're looking at an estimator. Unbiased means that the sample mean will be equal to the population mean. And I can tell that, so if like these multiple samples, these are called sampling distributions, if they have the same mean as my population, I have an unbiased statistic. So as I'm looking right here, anything with 75 in the center is going to be a unbiased. So if I look A, C, and D, when I draw in a line that's right at about the median or mean of the distribution, I see that the mean of all those is 75, and statistics B is not, it's higher. So A, C, and D are unbiased. If I'm trying to choose between A and B, if I look at A and I look at B, A would be better since it's unbiased. Let's take a look for the next choice for part C. It's asking whether C or D would be better. Both of these two are unbiased, but C would be better since it has less variation. And I'd be closer. All right, now for your response number 2 is about linear regression. Max is doing research on the wins for Major League Baseball teams and how that affected attendance for the 2018 season. He collected data on the number of wins and the average attendance per game for 30 baseball teams, and then he used computer software to find the least squares regression line. All right, so let's take a look. I've got the scatter plot. Here's the regression output. And it says write the equation of the least squares regression line, making sure I identify my variables. So my least squares regression line, I start in this first column right here. The y hat equals 10, 0, 8, 3, 4. This is my y-intercept, so that's where I start. Down below it is the slope, plus 235x. So there's my equation. X is my number of wins. That's here on that chart. And y is the average attendance. I get that from the graph. Okay, now it asks us to interpret the slope. So the slope, the predicted attendance increased 235 people for each additional game won. It's the change in y, predicted change in y for each unit of x. 2C asks if it's why it is not reasonable to use the least squares regression model to predict attendance per game for 0 wins. It's not reasonable to use this to estimate for 0 wins because there was no team that had less than 60 wins. This would be extrapolation and might lead to unaccounted for variation. So I want to make sure I stick with the data that I have, and 0 is a good ways out. Okay, if the 0.64 wins and attendance and 4,786 people per game is removed from the data set and new regression analysis is conducted, how would the following be impacted? Explain your reasoning. Okay, I'm going to identify this point. That point is right here, kind of at the beginning of the smaller side of x. 2D asks, what is the correlation coefficient? To find that, I need to square root r squared. R squared is 0.1229, so I square root that, and I get 0.3506. And then 2E asks how the slope would change. If this point, it is smaller than the x mean, and so it's going to pull that line up towards it, which would actually be decreasing the slope. So if I remove it, the slope is going to increase. The point has x coordinate below the x bar, and the y coordinate above the bar, above y bar. So having that point will make the line more negative, go towards a negative slope, and so removing it would kind of make it more positive. The least squares regression line always goes through that point x bar, y bar. The dimension point would pull the left end, a line tilting up and tilting the right end down, which would decrease the slope. How would the correlation coefficient change? The correlation would increase. That point is far removed from the least squares regression line in the y direction. So removing it would make less scatter and a stronger positive correlation. For response number 3, an article published the results of a study that was done to investigate the connection between Alzheimer's disease and smoking. The article claimed that the study had found a strong association between Alzheimer's and smoking. The study tracked the medical histories of 23,435 men and women for 25 years. The findings from the study were that for those who smoked at least 2 packs of cigarettes a day, the risk of developing Alzheimer's disease was 2.5 times greater than those who did not smoke. So 3A asked to find the explanatory variable. The explanatory variable, it's actually categorical, and it's those who smoked at least 2 packs of cigarettes a day. So they could have measured this in a quantitative way. They decided categorical was just smoking 2 packs a day or not. And now we wanted the response, and that was whether the people in this 25-year study, whether they developed the Alzheimer's disease or not. So we have 2 categorical variables. Is the study an experiment or observational study? Justify your answer. The study was observational since they only followed people and measured their behavior. They did not impose any treatments. They didn't make anybody smoke. They just saw whether they did or not. For the study, the amount of weekly exercise a person gets, no regular exercise or regular exercise, could be a possibly confounding variable. Explain how the amount of exercise could be a confounding variable in this study. So those who smoke more than 2 packs a day are less likely to exercise regularly. If there's a difference in Alzheimer's rates, you would be unable to determine if the difference was due to the smoking or the lack of exercise. So to get a full response here, you want to explain the association between smoking and exercise, right? So here I draw a connection that the smoking group is also probably a less exercise group. They're associated. And then I need to make sure I can say I can't tell if a change in response in the Alzheimer's was due to the smoking or the exercise, since they're both, both of those are associated already. Okay, for the study, okay, for response number 4, we have a newspaper company in San Jose conducted a survey of adults to investigate whether there's an association between highest level of educational achievement and primary source for news. The newspaper company took a random sample of 2,500 adults in the city, and here's this 2A table. So 4A is asking that if an adult is randomly selected, what is the probability that the selected adult is a college graduate or obtains news primarily from the internet? So let's look at where those are. My college graduate column right here, that's all those people. There's 693 total. My internet row is the other direction, and I have all this 687. If I add just those 2 totals, like I have down here, right, P or C, that means I really need all of these people. I have to be careful because that 245 is counted twice, so I want to subtract it out. And my final answer is 1,135 divided by 2,500, and that's 0.454. Okay, and if adult is to be randomly selected from the sample, what is the probability that the selected adult obtains news primarily from the internet? So my internet, is across the side here. My internet is that 687, and I'm selecting it from the total population, so I do 687 divided by 2,500, and I get 0.2748. Given that an adult who is a college graduate is to be selected, what's the probability that that adult obtains their news from the internet? So now, instead of going for the total, I'm only going from the college graduate. So I go 245 divided by 693. Whereas before I was going from the total column. And I get my final answer. It says 245 or 693, 0.3535. Now it says when selecting an adult at random sample, are the events, is a college graduate and obtains news primarily from the internet, independent, justify. And if I look at these two, really one, I was going from the total 687 out of 2,500. The other, I was going from the college graduate, 245 out of 693. And if I was to graph these percentages are not equal, right? The college graduate was more. So they're not independent. Getting news from the internet has a higher probability in the college group than in the whole sample. Okay, so let's go ahead on to the last, that was the last question, everybody. Hope that this was helpful. Good luck studying for your final, and see you soon.